Hello, everybody. Welcome today to our live stream, our Level Up Your GenAI Chatbot with GraphRag and LangChain. I am David Jones-Gilardi, Developer Relations Engineer, and I'm joined today once again by the awesome Charna Parkey. Hi, Charna.
Hello, good to be back.
Right? I know. We did this, like a month ago, I believe.
Yeah.
And did a month ago we kind of introduced like folks to GraphRag. Honestly, for those of you who are new to us, or if you've come back before and you're a regular, hello, how are you doing? If you watch the previous episode of this, Charna was essentially teaching myself and all of you about GraphRag and how all the stuff works and everything like that, right? So today we're gonna do something similar, but we're gonna move along. A lot has happened in the last month, right? There's been new movement in the GraphRag libraries and LangChain, the work that obviously Charna's been doing and such like that. So we're gonna explore all sorts of fun things. And with that, I see Dev, hello, and Alan Johns, hello there. Everybody, where are you from? Let us know. Put something there in the chat. And while you're doing that, so we can get an idea of kind of who's joining us today. Just a couple housekeeping things, right? So we do intend for these to be interactive, right? And interactive in the way that we encourage you, absolutely, ask questions, right? Like, as a matter of fact, the harder question you can throw at Charna, the better my life is, right? So,
Thank you.
right? So we get to put Charna on the spot. No, but really. So, I see Arizona, I see UK, great, from Colorado, France. Oh, hi, Dev from France. Oh, Conrad, hello there. Conrad Taylor, hey, Conrad. Hi, Michelle. Right. So just a couple of housekeeping items. If you do have a question that you want to ask, right, you should notice somewhere in the Crowdcast, whether it's on, it depends on if you're on a mobile or whatever, sometimes on the bottom, sometimes on the right-hand side, there's a little toolbar there, and there is a spot with a little Q&A, right? So what we ask for all of you is, if you do have a question to ask, please put it in the Q&A. Right? If you ask a question in the general chat, it's not like anyone's going to come and reprimand you or something, but I'll probably make a comment, hey, put that in the Q&A. Because that way it gives other people a chance to score those up, and it allows us to kind of like set them up while we're trying to answer and things like that. So again, put those in the Q&A. And down at the bottom, you'll see, matter of fact, you'll see a link right there. It says a guide to GraphRag. You'll see as we talk and as we're going through content, links will appear. We'll put them in the regular chat as well. These are resources for you. These are all like free resources, things that you can use as reference. All right, that's enough of me talking. Why don't we go ahead? And by the way, I see Pranav there from Chicago. I'm originally from Chicago, so hello, Pranav, the Southwest suburbs. So always glad to see another Chicagoan on there. Our food is the best, by the way. Let's just be very clear about that.
The last time I was in Chicago, actually, what I found most impressive was, I like the food, but there was a lot of independent fashion designers out there.
Oh, really?
Yeah, and it's been a while since I've been. I need to go back, but I got some of my favorite pieces that I can't let go of because they're just so unique, and I love it.
I love it. No, that's very cool. I'm very I kind of enjoy the fall winter weather clothes there.
Oh, yeah.
Because you're in like winter, like like cold times, like 6 months out of the year, so you got to have some style, right? So.
Yeah, it feels like you and I have swapped, right? Because I grew up in Florida, so there was no seasons. You'd wear, like, not even the t-shirts and polos that they made were of a lower weight cotton because it gets so hot. And then I moved to Seattle, where it's cold and rainy all the time. It's currently still raining. It hasn't stopped for the last couple of days. So now I get to do all of that, fall weather.
Well, see, now you're trapped inside doing all the GraphRag stuff, so that allows you to come and do these types of things. So
someone taught me, as long as you're wearing the right outfit, you're never trapped inside now.
Yeah, I like that. I like that. So with that, so what is it? We mentioned a moment ago that we're gonna not only kind of intro folks again to GraphRag, but then also kind of bring everybody up to date on what's the latest. So Charna, what do you have for us today?
Yeah, a lot has happened in the last month. I think last time we briefly talked about sort of a benchmark comparison that we had made between traditional knowledge graphs and that are entity-centric knowledge graphs and content-centric knowledge graphs. So that post is out there. The repo is available. If you read the post, the repo is available. That one is currently built on the implementation we made on the Cassandra GraphVectorStore, the open source version. I've adapted that to the new AstraDB GraphVectorStore that works with our cloud version. And we've done a number of sort of feature additions so that we can build this in LangFlow, that you can extract links in different ways. So it's sort of a lot of engineering work has happened. And we've had a number of customers who have been actually using real data to actually get apps ready for production. So I've got a number of different ways to explain how things work, as I've had to explain this to a number of different people with different technical backgrounds. So I think, maybe we start with something like the demo we did last time, and then we can dive deeper into all of the pieces of it.
I think that's a great idea, because for our audience, right, and for those of you, matter of fact, for those of you who are with us today, let us know. Give us a thumbs up or a thumbs down, actually. Do you know what GraphRag is? Are you familiar with GraphRag? Because I think, a lot of us now, I think, after 2-something years of this whole generative AI explosion, RAG, retrieval augmented generation, definitely, a term that's been around a lot and everything. I think more and more people are getting a good idea of what that is. But then what is this GraphRag? And I do see some, oh, hi, Matt. I see some folks that are saying yes and everything like that. Oh, I love it. I love it, Avelo. Yeah, that's great. Okay. Prasad doesn't know. So so there's some folks here. I think it would be good if we just give a basic primer on the GraphRag stuff. And I think that sets up what you were just talking about, and we can kind of demonstrate that with the app.
Absolutely. Okay, so I have a couple of slides actually that maybe would be helpful to visualize some of this for folks.
Yeah, that sounds great.
Then let me.
There we go. And Conrad saying, not familiar with GraphRag, and why do we need it? So I think we're gonna tee that up right now.
All right, So I don't know if folks have used a lot of RAG techniques before, but one of the things that RAG helps you do is to bring your data or data stored in a database into the context of an LLM. So it could be for a chat-based conversation where you need context to be able to answer these questions. Could be for an agent-based system where the LLM is gathering context to take action, or to do even offline planning. So RAG is super helpful in all of these different contexts. But when we say RAG, it doesn't need to be one thing or another. It doesn't have to be a vector database. It doesn't have to be a SQL database. It could be you're calling an API. It could be you're doing a search on the internet. Any information that you're retrieving.
Retrieve data that you can put into the context of the LLM. It doesn't have to be a data or whatever.
Exactly. And we as humans have different sort of mental models of the world. So as you start to think about how did you learn as you grew up, how does the social norms work? How do I, there are 100 different ways to load the dishwasher. I'm laughing because this is
like that, actually. That's a good point.
But some of them might be more efficient. Some of them might get things cleaner. Some of them might cause fights in your household. Who knows? But there are just things that you learn that are not always directly connected. That the line from point A to point B just doesn't make sense until and then it's connected in your brain sort of forever. And we have this idea, even when we go to college, and I'll share the slides in a second, but even when we go to college, as we progress and we learn topics, we end up with this sort of syndrome where we don't remember what we don't know. And then you go to teach someone that, and you start at such a high level that they can't get to where you're at, because you have to kind of walk this path for them. So I think of, let's see, slideshow, there we go. I think of GraphRag as a way to relate information that is seemingly unrelated, right? There are two different kinds of graphs. A lot of folks who know about GraphRag think about these fine-grained, entity-centric knowledge graphs on the left, where you've got a document and you extract the names of people or the names of countries or the names of, let's say, my mom is the name at the top, and then she's related to me because she's my mother, and then maybe she's related to her brother on the right. But when we're talking about the world of LLMs, the thing that they're uniquely good at is using lots and lots of words to produce lots and lots of other words and understanding.
Yeah, I like that. That's very
right? This is sort of all about the words, all about the language. That's why we call it a large language model. And so on the right, what we see is we're not extracting anything from this document. We are using the chunks of the document as if you were using a vector store. So, if you ingested an article or all of Wikipedia, for example, you can't just dump it all in there, right? There are things about retrieval with vector search that means we have to chunk it, maybe at the sentence level, maybe at the paragraph level, maybe a certain number of characters. But once you chunk a document, you've lost context. Maybe you could try to use overlapping windows or something, but you've lost the structured information that somehow this came from the same article. Or in the case of movies, maybe this was a review related to this movie. Or if
when you're looking at the database, you're looking at the chunk, I should say. Then if you read the chunk on its own without that relationship, it's just, okay, this is a chunk of text with its own little internal context, if you will. And this is another chunk with its own internal context, but you're missing the linkage, is what I'm hearing.
Yeah, exactly.
Okay.
And so when you miss that linkage, then you are going to get sort of suboptimal results when you retrieve the information. You'll do a semantic search and you'll get back chunk 1, but not 2 or 3. And you can relate all of these pieces of information together. There are many kinds more information that we can actually leverage and that we do leverage in something like Graph. Maybe you want to put product names in there. Maybe you want to have hyperlinks. Maybe you want to use the curated knowledge graph information that you made in the traditional knowledge graph to link the chunks together and do some sort of hybrid situation. All of this information that you have, you can link together. And when you do, you can start to retrieve information that you couldn't before.
Okay.
So when you ask a question, it'll do a vector search, get the semantically similar question, but also retrieve chunks that are related. This question links to this manual, which has this diagram, and now your LLM can give you a more holistic result.
Okay.
So I'm going to pause there and see if that kind of gives a definition of GraphRag, and we'll kind of wait on how to build it.
Yeah, and I almost wonder too, this is going back to Conrad's comment here, not familiar with GraphRag and why do we need it, right? So from what I understand, what you just explained a moment ago, where like a traditional vector search or traditional methods to RAG, right, to augment the context of an LLM, at times may be missing some context after you've chunked information and such like that. Right. So then we need some mechanism to increase. Essentially, we're trying to increase the accuracy and the relevancy of our RAG results. Right.
We are. Yeah. And part of the, I would say, difference between typical RAG or using a traditional knowledge graph and using a content-centric knowledge graph is here you now have a process to handle sort of those situations where your chatbot gets in a situation where it's like, I don't have the context for that.
Right.
This isn't actually, it's an iterative process, right? If you already knew, and I get this question a lot, like if you already knew what questions your users were going to ask, then you would just chunk your data and make a data model that could exactly serve all of those questions. And you wouldn't need a way to link information together or to evolve over time to retrieve the right kinds of context. But you don't know that, right? And there are two things that happen.
Right.
Sometimes your underlying data is changing, and definitely your users' expectations are changing. Like when I think a great example is the one we showed last time with the movies database. 10 years ago, what I expected out of Netflix was vastly different than what I expect from them today.
Right.
And now, especially with GenAI, like I would like to be able to ask any question that maybe the transcript of the movie would be able to answer for me so that I could get to the right thing. We're not there yet, obviously, like that feature isn't available, but I've changed. And so those two things.
You don't want DVDs being sent to your house anymore? Like, I guess that was longer than 10 years ago, though.
I don't know what I would do with them. Like, I don't know, stick them, make a little CD curtain on the wall. Like, so it is essentially a RAG chatbot, but it is not just a traditional knowledge graph. It is linking chunks of vector text together with structured data or other information.
Okay, and you just mentioned something pretty interesting there. You mentioned last time, we showed that demo app, right? That demonstrates the difference between a regular similarity search or a regular RAG kind of similarity search, and then one using a knowledge graph, right? Graph RAG.
Yeah.
Would it be worth kind of bringing that up? I think that's kind of good to set up, because I love the example that you gave last time. Because that example to me, like for me personally, is so for everybody here, right? The last time Charna and I talked, I hadn't actually worked on GraphRag yet. And since that time, I've done some work in it, and I've gone through some of my own development and everything. And there's some things that I've kind of learned, but this example that she's showing right now was really kind of game changing for me internally to understand better what was actually going on. Right. So I see, Charna, you're already doing an example. Can you kind of break this down a little bit?
Yeah. So my first search, this one should be easy for vector similarity to answer, because this is often in the description of movies, is movies with a strong female lead. That's part of the categories. Like if you go to any movie database, that this is kind of how they categorize things. This is sometimes how I find the next movie I'm going to watch. So the similarity search searches for 10 chunks and retrieves them based upon this question. So strong female lead, and it gets these three answers: Wonder Woman, Damsel, and Red Sparrow. That's relatively easy. We get similar results on the right-hand side. And maybe there are a few more of them, but we both are reasonable answers, right? Okay. So totally fine. But what's the difference is on the right, we're returning the first 10 results, and we are walking the graph to get to additional related information. And in this instance, maybe it doesn't need to walk that graph, but if I ask a more complex question, something that isn't contained in the chunks that I had put in there, maybe movies with a strong female lead, not about love, it's going to have to find more information. This isn't typically something that you put in the description of a movie, right?
Oh, right. Because, this is a great point right here, right? Going back to what you're talking about with those chunks, that in this case, the traditional traversal, the similarity search here is based off of the chunks of text that it has available in the database. So when it looks, it grabs a chunk, or it tries to, but to your point, it doesn't have anything about strong female leads and love. Right. So then it comes up empty in that particular case. Okay. But I can see here on the right-hand side, I'm seeing something different going on the GraphRag side.
Yeah. So here we see that Furiosa, the Mad Max saga, is a movie with strong female lead that is not primarily about love. And then it tells us what it focuses on, about her struggle for survival in an apocalyptic world. And you'll notice that it even says primarily, right? There are always going to be relationships in movies, but is the focus of the movie this topic? Are we following a journey of, the only thing the woman can do is fall in love with somebody or not, and then her story's over? Or Hidden Figures. This is a great one, right? There's definitely relationships in that one as well. But the point of the movie is the brilliant African-American women at NASA. And it highlights their contributions to science and history. And it focuses on their professional achievements, although there are romantic storylines in it as well. But that is not the purpose of the movie. So we get different chunks to be related to one another. Now, the data itself, maybe it was a long review or an article that a reporter wrote, or maybe someone like me who wrote a blog about this that we chunked up and related to the movie that allowed us to get this information. We'd have to know exactly what was in that data, but there's something in there. I believe in this data set, it was that there was plot data as well as description data, and that's how it could get to the plot. But you could build this in any number of ways if you wanted to index reviews and articles and podcasts, and oh, by the way, have that connected to your movie database.
Got you. Okay, so like I see a couple things here. We have one question from Renee, Renee Ugart, that I think is related to this, because I think it gets into like the structural differences. And then there's what we're seeing on the screen. When I'm looking at the screen here on the GraphRag side, I see more than just num results. I see a depth. I see diversity in this relevance slider and things like that. And what I want to do is I'm gonna ask you a multifaceted question, answer it however you will. But Renee's question is, how do these relations differ from those in a traditional relational database? When would one use one over the other, right? So there's actually kind of three concepts going around here, right? You've got traditional relational database, then you have like unstructured data, and then this whole graph thing. Can you maybe do those together a little bit?
Sure. Let me share another screen. Essentially, in my mind, these two things are connected together. So maybe I'll start with this one. Okay. So on the left is our unstructured data. It's our paragraphs, it's our documents that we have chunked up and where we would typically ingest into a vector database. On the right could be data that is in a traditional relational database. You just, oftentimes you'll store like pointers to pictures or links, like whatever is used to serve the Wikipedia website is probably, although I know they have a knowledge graph too, but it is stored in a relational database. Like this article is related to this thing, etc. But the uniqueness here is that you get the ability to do 3 or 4 different kinds of searches in a single database, not having to build 3 or 4 different ones to get a keyword search, to get a vector search, to get a traversal search, to get an MMR search. Okay.
Right. Okay.
So it is essentially combining together your unstructured data and your structured data into the same place. And it gives me another piece of information. This document on the left, I define how it links. What direction can I walk this graph? So in this highlighted arrow, this is an outgoing link from document 1 to document 2. Document 2 cannot go back to document 1 using this URL. But document 1 is connected bidirectionally to this keyword Galaxy S24. So any other document that also has that keyword can get back and forth to each other. So oftentimes, like I want to know something about my phone, well, I need sort of all of the documents about that phone to figure out what's wrong with it, right? So I could get from, let's see, is there a way here? I think the only way that these two are currently connected is the URL. But if we had, for some reason, document 2 pointed to Galaxy, you could get from document 2 back to document 1. So that link and that idea of directionality is something that's added. So that's kind of the first part.
Okay.
The second part, let me see if I can here. So like we said before, when you do a vector search, you retrieve that first set of documents, and then we look and see if there are edges, and we check our depth. So if the depth is 2, then I'll go get that first set of edges and retrieve the next layer of chunks. And then I'll look at those edges and I'll retrieve the next set of chunks. This MMR search, the maximal marginal relevance search, adds a step. There's a re-ranker. that once I get all of those chunks back, I will now look at them in context of the original question and re-rank those results. Because as we know,
Okay.
LLMs need the sort of most relevant, most contextual results at the top. And that step can give us better results than using just a structured database alone or an unstructured database alone. And it gives us more controls over, like you mentioned before, diversity versus relevance. So if I looked at that slider again, I can control this re-ranker because do I want it to be super literal or do I want it to have diverse information in it? And so if we were to go back, maybe if I stop sharing this one and go back to that demo and play with the slider, we can see what that can do. So dash, that's what that tab is. So if I drag this over here and I search again, hopefully I get different results. They were the same ones.
It could be dependent on your data set too.
It's definitely dependent on your data set. If it's available to have more diverse versus more relevant. Yeah, it looks like these are the only two that are able to come back.
In that particular search or whatever, yeah.
Yeah. Oh, here's another one. So Gravity is another movie that's a thriller. Now.
Yeah, because that one really doesn't have much about love, but you're saying, hey, I want you to really go down on the diversity end, right? Give me more diverse results, less relevance. And once you got past a certain threshold, now that one came up. As
right?
Part of the scoring. Okay.
Like somewhere there was something specific about gender barriers or romance, etc.
Right.
That pulled back more in the similarity, and this one is, different.
Okay.
Yeah. So let me go back to, did I answer the question? So let me look back at, okay. So yeah, if you're in a different, I wouldn't say like throw away the data that you have, right? How do you know when to use one or the other? It's based upon your use case, and there are trade-offs to be had, right? So if you had a traditional knowledge graph and you already spent the money to build that, like $70,000 often to build like a single knowledge graph, you should use it. Now, should you use that information on its own? Maybe not, right? You may want to use it to connect your unstructured documents. Maybe you want to use it with your vector database or with your structured database. You also have considerations like latency. So if you have an application that has a strict end user experience requirement of certain milliseconds, you may not be able to traverse a large graph. So you can still get some of the benefits, but maybe you can only walk one hop away. Or maybe you can't use the MMR, maybe you can only traverse and you have to use an LLM, et cetera. So you have to take some of these considerations into account. And sometimes you just need to take a structured database call and an unstructured, maybe a vector search, and then throw all of that data at an LLM. I've seen that be relatively expensive when you're dumping all that context, and a little iffy on if the LLM can interpret all of that in the right way.
Okay. Yeah. I got you. So, all right. So we've talked a bit about, obviously, what GraphRag is, a little demo there and that kind of deal. I guess what I'm curious, and I'm looking at some of the questions and such, like, how do we then take the explanations you just given, right? We talked about how you mentioned the Wikipedia stuff where we're talking about this movie example, where, we see that there's a difference between the traversal search and what is going on the GraphRag side. But then as developers, right? Because I know some of the folks on here, right, that I recognize these names, like, how do they then take that and do something with it? Like, how do you create that graph and work with GraphRag and all that?
Absolutely. So and you have some experience with this now because you've played with it.
Yeah.
I think that there are places to start, and that to get an understanding and an intuitive feel for what do all of these traversals do, what do all of these query types do. And then there's sort of this iteration where you end up in a place where you're going to choose what works for your use case. So if I were to look at, say, this. So there's a bunch of extractors out there in the LangChain community. There's link extractors and keyword extractors and hierarchy extractors. These can be used for any kind of like NLP task for the entity-centric knowledge graphs, but also for the content-centric knowledge graphs.
Okay.
So it's really great to get started with these type of extractors because you don't really know what is important in your data yet, what's possible to get out of your data. And so you can use these to get a set of links that you can start with. And then if you've ever used a vector store in LangChain, you're going to substitute out an Astra DB GraphVectorStore or a Cassandra GraphVectorStore, depending on which one you're using. And it uses the same sort of like document concept that you're using in all of the other places that you're using in LangChain. And it gives you these different kinds of traversals. So what I would say is like, get a data set, maybe pick one that's publicly available. I'll show you one here in a second for the Wikipedia data set, and then start doing some extraction. See what's possible, build a graph. Now, because it's relatively cheap to build a graph of this kind, you're going to probably do this 3 or 4 different times, because what you'll find is initially, oh, I got a lot of noise from just auto extracting and throwing everything in there. And I can't really answer my question because the graph is so hyper connected. I'm getting too many results back. I need to actually reduce the number of connections, or I need to add metadata so that I can do a filter on my data set while I'm doing these different kinds of queries. And so, I don't know, I guess maybe I'll throw the question back to you. Was that sort of your experience as well when you were playing with it?
Yeah, so my experience, can you put that back actually?
Oh, sure, yeah.
Yeah, put that back up there. I was, funny enough, I was in the middle of trying to get I was pulling the GraphRag, that demo app repo for Dom. There's a couple of people have asked about where that code is.
Mm-hmm.
So I was actually looking for that. Yeah, so as far as like this, like, being able to get the results and everything, like what you're showing here is largely similar to what I ended up doing. I think the difference in, I would love if this is something you're going to talk about here today is, I think my difference was generating the graph, right? Like in getting the point where, like and correct me if I'm wrong, by the way. Oh, here we go. Yes. That's it right there. So like, I don't know if this is changing any of the newest kind of iterations of what's happened in the various GraphRag repositories or anything. But you guys can all see here, as everyone can see, like you'll see that like that hierarchy link extractor, the keyword link extractor, the Gliner link extractor. And there's all these like automated extractors, right? And so when I started with those, and they do a really nice job of like automatically going and pulling all of this information into the graph. But what I found, it was a bit noisy, right? So like the link extractor is a really good example. The app, that demo app there, that GraphRag one, actually pulls information from a website. And so you have lots of hyperlinks that are in all sorts of documents. And it's going to go through, and without some kind of filtering or something like that, it's going to pull all the hyperlinks, regardless if they're really relevant, right? And so,
if there are ads on that page, and
yes,
it's going to pull an ad that's completely unrelated. You don't want that.
Right. So for like, from what you were talking about before, like from like the ease of being able to use the libraries to actually search and perform the, the various traversals, the MMR search or something, whatever, that was actually relatively easy. I think the more challenging part was putting the graph together. But what I learned, though, is that the way I was doing it, which was essentially just grabbing everything and throwing it in there, is not quite the right way to go about it.
Yeah.
Right?
Yeah. So let me share this tab instead. And I mentioned briefly that the repo for the, okay, I'm going to go back and let me introduce this article, and then we'll go into the notebook. So in this article linked here at the bottom, there's a Hacker Noon article. It's also on our blog now. Ben Chambers wanted to compare the difference in results between just using an entity-centric knowledge graph and using a content-centric knowledge graph, both in cost and in its ability to answer questions. So it's a great read. I love it. There is a repo in that article that you can go use it. It's using the Cassandra GraphVectorStore. I didn't want to set that up locally on my machine, so I readapted that into this notebook that I'll show you in a second that uses the AstraDB GraphVectorStore, and I'm happy to go make that available in the repo as well. So what you'll notice is the cost, it cost $60,000 to load all of Wikipedia into the entity-centric knowledge graph, because it had to go and extract all of those entities. And we used an LLM graph transformer to get all of those entities and links out of it.
Okay.
And that cost of the LLMs is very high. So, it's $59,125 just on the extraction, not even talking about the full loading and all of that. But in the GraphVectorStore, and hours and hours and hours of time. In the GraphVectorStore, it's near zero. I would say it cost me, for all of the embeddings, probably $50 to load all of Wikipedia into AstraDB. And so when I show this notebook, I want to show you a way, instead of using those auto link extractors, that we wrote sort of a manual link extractor. So in this function here, this parse document, when you read the data that's available in this publicly available data set, I believe it's licensed under Apache.
A little bit, Charna, sorry.
Yeah, let me see if I can. There we go. Here
we go. And by the way, just so you know, I think, Dino asked a question. Do you use an LLM to help create the queries and build the graph structure? And right here, what Charna is showing you, no, you don't need an LLM, right? You can actually use these other methods, and this is one of those methods that you're seeing right now.
Yeah, especially if that data exists. If it doesn't, you may decide to use an LLM, or you could use traditional NLP techniques, etc. LLMs are great when you need to somehow transform what's actually in the document to something else. So what you'll notice in the LLM transformer for the traditional knowledge graph is that there's an entity being talked about, but using a different word. Think about people using NYC versus New York City, right? You need it to be the same entity when you're trying to link them together in a traditional knowledge graph. We don't need that here. You just have chunks of text, and you need the link to be the same ID or the same URL or the same keyword. But we don't have to extract it by transforming the concept of a document. We can extract it by transforming the metadata of a document.
Right.
And the good news is that, and let me actually, I put it here. So this data set, there's this data, there's a project called the Wiki Multi-Hop that they've already broken apart the sentences and structure of Wikipedia such that it is difficult to do complex reasoning, so that you must do multi-hops. So I started from there, so I didn't have to do all of the chunking myself. But we've started from here for both the traditional and the content-centric. And so if you're going to use this particular data set, cite this original paper, but it is freely available for you to use for any type of research that you want to do. And then inside of this parsing document, you'll notice that I'm doing outgoing links.
Oh, okay.
For the links that are inside of paragraphs. And
okay.
And that's important, because when if I open Wikipedia and I actually try
you don't want the ads, and you don't want all the other junk, essentially, right?
Essentially, yeah. So let's share this tab. I'm on Wikipedia. I've got, the actual pages here, but I've always got this donate now somewhere. I get pop-ups places. And so maybe I want to search for Afghanistan. And inside of these paragraphs, I've got Central Asia link, South Asia link, Pakistan link, et cetera. But that information, what is South Asia, is not contained in this article. It is linked out.
Right.
So I'm walking the links in this paragraph, and I'm actually linking them as outgoing links as they are on Wikipedia.
Got you. So now we're putting in the connective tissue, right? Because if I were to just take that document that you just showed and chunk through it, and then put that into my vector store or whatever for my RAG application, and then go to search on, I may get a hit on something about Afghanistan or whatever, but then any of that supporting information I would not have, right? Exactly. But now we're pulling, what I'm seeing is you're adding the link with this outgoing link to the metadata of that document chunk. So then if I were using like GraphRag or whatever, now I can start to tease out those types of relationships.
Yeah. And by the way, I'm also adding that link, that incoming link as well to
the other way.
Yeah.
Okay.
So if I actually go down to an example of testing this query, so I've set up a bunch of retrievers here. So the GraphVectorStore, I think I showed it in this slide, it has just a similarity retriever. If you set the depth to 0, you can do vector similarity just fine. If you add a depth to it, then you're doing traversal. If you do an MMR traversal type, that's where you get that re-ranker. And so you get a bunch more parameters that you can do in an MMR re-ranker, like what's the diversity, etc.
Oh, I see. So there's another function in there that is not MMR. Like you can, okay, I got you.
And by the way, you can do all of these with a metadata filter as well. So if you need to take that large set and limit it down to only keywords of this, you can do a metadata filter and you can do an MMR traversal at the same time.
Oh, okay.
Or a vector search at the same time. Yeah.
Okay.
So here I set up a basic retriever, give me 10 chunks in the similarity search. And here I set up an MMR traversal, give me 10 similarity chunks, and then walk the graph. So this could be, as you saw in Wikipedia, like if there were 10 links for every paragraph that I get returned, I would get 10 times 10, right? So it's a large data set, which is why we have our timeout up here a little bit larger.
I see.
And then I did I pulled in just the basic RAG prompt from LangChain. I didn't change it at all. And I used my basic retriever. I formatted the doc, prompt LLM parser. Same here. This is the MMR retriever for graph, prompt LLM output parser. So everything after this is the same. And I asked this question: what are the regions of Afghanistan? And, oh, this is the wrong tab. This one is not run. Share this tab instead. What are the regions? I have a playground, and then I've got the clean one that I'm going to share with you guys later. So what are the regions of Afghanistan? And I did the graph chain first. The regions of Afghanistan, and for those that don't know, before I get into this, this is an area that is constantly changing, right? And so it is not an easy question to answer.
Right.
You've got the definitions from the United Nations. You've got the definitions from the cricket tournaments. You've got then there are regions, and then there are sub-regions. It's a complex question. And so if your data set has changing data, like we talked about before, or has multiple instances of data, sometimes you cannot answer the question with a basic similarity search. So regions of Afghanistan, as defined for this particular tournament, include these 6 regions: 1, 2, 3, 4, 5, 6. And if I actually go look that up on the internet, this was the schedule and results, somewhere on the internet for these different ones. I'll show you down here. Those were the 6 regions defined for that tournament in 2018. By the way, this year there are only 5 regions determined for the tournament, but it was able to give me an answer. The basic chain cannot. It says, like, the UN defined 7 subregions for assistance planning, grouped into 3 major regions, but I don't know what they are. They're not provided in the context because it couldn't follow the links in that paragraph.
Got you. Okay.
And so this, I put a little bit of messy stuff in here. If you want to take this out of a chain and you want to just see what that retrieval looks like, I did it as, down here in this retrieval. It's a little messy.
Oh, are you back on your collab, by the way? Because I'm still seeing the ESPN site. Sorry. There we go.
Okay, so let's go back. So this is grouped into 3 main regions, specific name not provided. So if we look at like the actual retriever, we can break it out of the chain and we can look exactly what documents are being retrieved. It looks messy because there are so many links, but I want you to see a little bit of what's in here. You have a document type, you have metadata, and you have links. So there's this link, it's going out to this tag. Now the tag can be anything, right? It can be a number, it can be a word. What we care about is what it's linked to. And so even though we don't see that here, this is how it's walking. So I do recommend, if you can, make these tags very small, because you are taking up space in a database. It doesn't.
You're going to repeat them a lot, aren't you? Right?
Yeah, you're going to repeat them a lot.
Got you.
And they often need to be unique. So in a travel use case, for example, we thought, oh, we'll just use the neighborhood keyword. And that'll be fine. Well, no, there's a Fremont in California. There's a Fremont in Seattle. You can't do that. You need a unique identifier to actually link it together. Otherwise, it's, telling you, oh, the Empire State Building is in Seattle. And you're like, it's not. So in this way, you've got this metadata and you've got the page content. And because we can get multiple documents, we have 10 documents here, we can start to piece all of this together into the context. The same is true, by the way. You get the same sort of formatted output from a normal traversal, or if you wanted to do this with a similarity search, it's the same kind of output here.
Right.
The links are still there when you do a vector similarity search, but it doesn't walk them. And so you don't get the linked information.
Got it. And by the way, just something to point out, like, I believe it looks like the notebook has been shared there. You should see that Google Colab Wikipedia link that's at the bottom of the crowdcast. So for those who are watching and stuff, you're like, well, great, she's showing this stuff. I would love to actually be able to like get access to this. But she's talking about like how messy all that looks like with the links and everything. Obviously, in your code, you're building up that metadata, right? But that's not something that you actually have to like worry about.
Look at
code,
or yeah,
right? Or
no.
When you're saying, hey, give me a depth of 2, do this MMR traversal, that is traversing essentially those edges and such like that. Yeah,
exactly.
Now there's a question here from Marcus. I think it's totally relevant to what you were just showing. I know the answer, but I'm going to let you, because it's more fun when you answer things.
Let me know if I give the right answer.
Right. Yeah. Is it possible to manipulate these links? Right. And I see your response already. I can tell what it is. That was actually a big learning for me, Marcus, when I had done my initial like research into this, like when Charna and team were doing their thing, and I'm like, all right, I'm going to go build an app, because my job is to build these things and then go give them feedback. Right. And be like, hey, like what is going on here? But one of the first things I ran into as well is, well, a lot of the times I've already got my metadata. I've got my graph created. I don't want to have to go recreate the thing every time I need to make a little modification. Can I just go modify a particular like, item or an entity or something like that? And the answer is, as far as I understood and what I've done, is yes. And I see face is yes as well. Yeah. So you can absolutely modify those after and manipulate them after the fact.
And that's part of that process I was talking about in the beginning. Like if you have any form of, and I highly encourage you, if you have any kind of GenAI app out there, you should be logging a bunch of things. You should be logging whether or not the user was happy, whether or not the result was good, etc. And so what you can do is go back and say, oh, I hit a guardrail and my LLM said, I cannot answer that question, or I didn't have the right context. Anytime you get that, you can review it and say, hold on, I know my database has that information in it. Why didn't it happen? And so, yes, you can go say, oh, this manager is related to this project and this person is related to this project. And then you can say, give me everything that this person has done, or give me all of the work that this manager's team has produced this quarter, if you have information in there about the dates, etc. Right? You can start to get multi-hopped things. And if you want to add a new document type, you can do that in the same graph. I've had some folks say, well, I'm going to make a graph about, Slack, and I'm going to make a graph about the files in Google Drive, and then I'm going to make a graph about this other thing. If you do that, it's a little complicated to try and get the graphs connected together. You have to do multiple queries, etc. you can put all of those chunks in the same graph and then relate them. You can give them a type. You have control of metadata. It doesn't need to be only your links alone. And in fact, I encourage you to add metadata that you want to filter on. So if you want to put a type in there of document or a type of conversation, then when you retrieve, you can say, sure, use all of that graph to walk to the right chunks, but then filter at the end and just give me the documents. You can do that.
I like that. Okay.
Yeah. Like why use more tokens than you need to?
Yeah. Yeah. Right? And by the way, I mean, the soapbox I won't get on right now is the one I hear all the time. I'm going to slightly do it, but is like, I get, well, hey, context windows and token limits and stuff that the LLMs have gotten absolutely huge. Does it even matter? It totally does. The LLMs are super, super good at what they do when you give them relevant information. If you just like throw everything at them, you muddy the waters, right? And not only that, you're paying for all those tokens and it's slower processing, right? So the more relevant and accurate information you can give them out of the gate, the better your answers are going to be by far. Mm-hmm.
We'll take the Afghanistan example. If I let the retriever give me 100 different chunks, I might end up with the UN definition, the 2018 definition, the 2020 definition, and then you throw all of that, and it's like, sometimes the LLM will say, oh, it's been a progression over time, and here's what it actually was. If you're using the expensive call, maybe. But oftentimes it's like, well, I don't know because it's changed, and I don't actually know what you're looking for. Give me more information.
Right, and something like that, you want to ensure that you're getting the latest information, that you're accurate and stuff. Yeah, I could totally see that. Now I see, so I see a question here from Dominic, and it's actually going to lead into another question. So the question is very simple on this one because I already answered it. Is how do we get the code for whatever chatbot Charna is using? I did drop it there. I'll go ahead and say chatbot. I'm going to drop this in the chat. Now, something I want to preface with this is that the code for that chatbot is now, like, it's still fully functional and all that, but it now is a little old, right? Because it was using a different method. But here's the thing I really want to point out, and this goes back to some of the code you were showing, Charna. When I originally was working on that, if you take a look at that code, you'll find that when I'm doing the data loading, I'm extracting all the things. I'm using the automated extractors. And what I've learned since is, we talked about this a little earlier, that's not really the best approach, not for your production thing, not for the thing you're actually going to use. For starting, for learning, for building my graph quickly, they were awesome. Yeah. But then once I understood what it was doing, like the link extractor is a really good one, right? I thought, by the way, Beautiful Soup, I thought did, if you're familiar with that, Beautiful Soup does a really nice job, actually, of pulling out really relevant stuff. It takes a lot more processing to do. But like putting separate from the link extractor, it'll extract all the links, all of them, right? Yeah. Even things in like your navigation and things that you really may not want. Right. And once I learned that, I was like, and this was what then I kind of learned from folks on the GraphRag team. And then what you were showing earlier, it's actually better, as I understand, to build out your own ontology. Like if you know that, like to your example, like you're only wanting, say, like the links in the paragraphs, or maybe you have very specific cases, like in the movie data set that I was working with, there were very specific links that I actually wanted. So it would have been better for me to just add those links with their metadata instead of just using the automatic extractor. But again, the extractors were really good to get off the ground, kind of thing. Yeah. Is that still true today?
Still true. And I would say in most of the cases, when I'm working on a production application, we don't start with extractors at all because they have some amount of structure that they already know is important. And so we start with their structure and we say, all right, you already have in your relational database these different types of things that you're using to serve your customer. How do we want to link that to your unstructured data? And how do we get it into Astra? Because again, latency is a concern. So you don't want to have to go do like a big query and then not know if you've got the latest data in there. Like it's just the time constraints of how long these queries are going to take in a different system for a chat application may not be great. And so we try to pull the relevant information into Astra into the links that they need. And I went through this with a customer the other day where she was like, well, let's just bidirectional link everything. And I was like, it won't be very expensive to learn this lesson. So let's do that. And then see why we don't do that. And she's like, okay. And we go through the process and she's like, huh. So let's not do that. I was like, yep, there we go. What direction do we want to go when we're walking things? What are the questions your users are asking?
Right there. I'm going to put you on the spot a little bit. Do you in the NoSQL world, right? We live mostly in the NoSQL world, and it's not like there isn't structure. There's absolutely structure in the NoSQL world, but the NoSQL world kind of like started this whole unstructured, like schemaless kind of thing, right? And so I think you look at the Mongos of the world, or if you look at like anything that has a document model, like Astra does as well in parts, and you're like, oh, okay, there's like schemaless thing. I just throw my stuff in there. I chunk my data. I just put it in there and go, right? Mm-hmm. But then in the relational world, this goes back to a question from earlier, right? By its default, you start with things like normalized forms. You're starting with, you have to really think about the structure of my data. How am I going to store it? What kind of connections and foreign key relationships am I going to have? That kind of deal. Mm-hmm. And so like, do you find now that with something like GraphRag, especially what you were just talking about, that, yeah, great, we have all this unstructured data that we can do things with. And LLMs are actually pretty amazing at being able to process and do useful things with it. But now it feels like the lesson I learned was actually, no, you got to sit down and think about that structure a little bit. It may not be the structure of the core data in your system, but it is the structure of the ontology of your graph. Like what's the directionality? Yeah. What's the data you want to pull out? Things like that.
Well, I would say that it's now we're in a hybrid world where if you start your graph vector store and you don't even want to make links, right? You just throw all your documents in there. You can do that. It's not going to traverse anything. It's going to give you your vector similarity, and that's fine. Like, you may not need to create those links. You probably will, by the way, as you start to get users. But you can then say, oh, I couldn't answer that one question, and you can sort of defer that thinking until you get a cleaner understanding of what structure is necessary. You can add a link at a time if you want to,
and you can see what it does. Yeah,
a category of links at a time, and then test and sort of like do an A/B. Often our customers are doing an A/B test side by side, get satisfaction results on these answers, get satisfaction, and maybe they do 5% of their traffic, and then they move it to 50% of their traffic when they see that it's successful, and then they go full swap on over to the other, backing database. But yeah, you can evolve that. So it's
right.
In a relational world, you're kind of screwed if you built the wrong structure and you tear it down and put it back. And in a document world, you didn't have to do that thinking, and you don't have the links there at all to use, and so you're kind of stuck because you can't relate it. In this hybrid world, throw it all in there and build it up, or throw it all in there and tear some of it down. You can delete links, right? You can say, nope, that didn't work, or make it outward link or an inward link, and that's perfectly fine.
You can update that on the fly too. Like, you can do it with your data that's already in there at rest, and you can just modify it. You don't have to like redo the whole thing.
Yeah, and I should mention, we are working on a partnership with Unstructured. They are building their enterprise platform.
Okay.
That's going to be in GA, I think, in December. But if you have access to the preview right now, there are AstraDB connectors in there, and you can hydrate using Unstructured any kind of extraction into Astra, and then you can convert that to a graph database and actually leverage all of those links. So we're going to make this even more seamless over time. All of that is to say, like, use whatever breakdown you need in the beginning to get the structure out, and start to sort of progress, because your data will change, your graph will change. And sort of, you can iteratively build this for relatively cheap.
Got you. And one last thing, I know we're at time actually right now. I did see a question from Dino, who is trying to better understand the hybrid approach pattern of using both a vector and GraphDB in a RAG app. We're kind of talking about that right now. And the one thing I wanted to like leave everyone with, right? And then Charna, I'll give you a moment as well, is like in with GraphRag, you're not talking about a separate graph database. You're actually talking about, you're essentially storing the graph, the ontology of the graph, everything in your actual metadata of your vector store in our case, right?
Exactly.
So it's just part of the chunks themselves, if you will.
It's part of the chunks themselves. And because that's the case, you don't actually have to build a traditional graph database. When you insert something, I have this visual thing of like these blobs like elbowing each other out of the way and like adding their links. It takes time to insert in a traditional graph world. In this hybrid world, you just add a piece of metadata and it traverses at query time. No one's shoving each other around, right? It's like you insert a row, that's it.
Yeah.
and then you're like, oh, now I need to go use that. And it's very fast. And knows the keyword to use to walk the link.
Okay. So my last question then for you to leave everybody with is, we have a lot of resources that we put into the chat there. There's all sorts of links. Is there one, putting you on the spot again, is there one in particular that you're like, hey, if you're going to get started with the stuff, right, you want to start coding, right? I could tell from some of the comments, we definitely have some coders in here. They want to get doing things and like explore. What would be the thing that you would give them? Totally putting Charna on the spot right now.
I really, yeah.
Oh, go ahead. Sorry, Charna.
Because I just converted this last night from the Cassandra GraphVectorStore to the AstroDB GraphVectorStore. I know the versions work together, so I would start with the Wikipedia one, just to get something where you can start to query and understand what's possible. So I would drop that link in there, but it is a big data set, and so it might be difficult to really fully do a 101 level for that one. So I would say there's probably a toy example that Brian Gotze wrote, and I don't know exactly where it's at, but let me get his profile. If we post a lot on Towards Data Science, and then we cross-post those to our blog. And so Brian does a lot of our Towards Data Science.
I see his Medium right here, right here at the bottom. This, I just put it in the chat for everybody.
There we go. Yeah. So go there. He's got a lot of smaller examples that as you're trying to, get the concepts and everything like that and learn how to do the trade-offs. I think his most recent article that he wrote, or maybe it was the Quest for Production, Easy to Start, Hard to Finish, talks about the different challenges you're going to hit along the way to move it out of just an experiment and into production. So I really liked that one. And it has some good examples in it. So kind of take a look at those examples. They're usually like code snippets inside of them. And that's where I would go. But if you want a big data set, because that's kind of how I like to do. I like to like dive into the deep end and kind of drown a little. I would go with the full Wikipedia set.
Okay. Let's see. All right. And try this. There we go. For some reason, when Marcus tried the Discord link, he said it was invalid. I did it. It worked for me. So hopefully that works better for you. I don't know why it was invalid for you there, Marcus. But hopefully
let me click on it. Let me see if it works for me.
Yeah, I launched my Discord just fine.
Yeah.
Okay.
It worked for me.
In a worst case, Marcus, if you ever need to, just like I told, let's see, here we go. Just like I said to Dominic earlier, I'm going to drop my LinkedIn. Feel free to reach out.
I can't see new chats.
All right. Yeah, if anybody, if you need any follow-up information or anything for those who joined us today, just reach out to me, reach out to, to Charna, either one of us, whether it's LinkedIn or Discord or something. I just dropped some links there. And feel free to follow up. I'd be more than happy to get you whatever information you need. And with that, I know we're 5 over, so we'll wrap it up. Thank you, everybody, for joining us today. Hopefully you learned a little something more about GraphRag, and I'd like to see what you build.
Let us know what you want the next one to be about. Do you want a specific use case? Do you want a specific data set? I'm happy to build something for you.
Yeah, no, I like that. As a matter of fact, I think while people are putting things in the chat, you can keep typing in that chat. If you have an idea, something you want to see, put it there and we'll grab it. Cool. All right. Thank you, everybody. Everybody take care. Thank you, Charna. And we'll see you all next time.
All right.
Bye.
Bye.